So we just finished sample problem 20.4, where we calculated the delta G of reaction for this chemical equation by using delta G equals delta H minus T delta S. And we used Appendix B to calculate both delta H and delta S parameters and then put them into that equation. What we're going to do with this problem is essentially look at the same chemical equation, but rather than having to use Appendix B twice and then a separate equation, we're going to use Appendix B one time, and we're going to use it, and we're going to use the third column, the delta G values. And what we'll see at the end is, mathematically, we're going to get the same answer. So let's go ahead then and work through that problem. All right, I'm going to rewrite my equation here just so that I have all my parts out where I need them. Okay. And now looking at my delta GF values from Appendix B. Units are still going to be kilojoules per mole. I get minus 296.3, minus 303.2, and minus 409.2. So delta G of my reaction, products minus reactants. So again, big brackets here to indicate I'm summing up my products here. 3 times minus 303.2 plus 1 times minus 409.2. Then I'm going to subtract off my reactants. 4 times minus 296.3. Okay. Work through this math, minus 134 kilojoules, which if you remember, if you looked at the previous problem, we had minus 133. So within kind of error of rounding and so forth, we have the same answer. Now, looking at the amount of work that we did for this problem and having to use Appendix B twice versus using Appendix B once, this was a lot easier to work through in this regard. But as we'll see in a little bit, an understanding of this equation is really important because it allows us to talk about concepts like entropy, enthalpy, compensation, and how there's a temperature dependence for reactions that aren't a win-win situation.